All right, so here are notes for section 5.1. Please copy out these definitions. So we can find the basic sign points from our unit circle just by analyzing sign at each of our quadrantal coordinates. Now we're going to take those values and we're going to plot them on the grid. Right, so all we have to do then is plot our points. So we said that sine at 0 was 0. So we put a 0 on. Sine at pi over 2 went up to 1. Sine at pi was back at 0. Sine at 3 pi over 2 was down to -1. And sine at 2 pi was up to 0. Now we're going to look at the negative rotation. So just looking at the table that you created. So you created a table, we're plotting those points. At negative pi, sine is down at negative pi over 2 is down at -1. At negative pi, sine is at 0. At negative 3 pi over 2, it's up to 1. And at negative 2 pi, it is back down to 0. Now when you connect these, it should make a nice curved wave. Okay? So we'll start, and we're just going to curve through our points. It should be a nice curvy wave, not pointy at all. And that would be your sine graph. All right, now that we've got it drawn, we can look up our information. So the first thing we're asked to find is the period. Now the period is when this graph repeats itself. Think about your unit circle. When does your unit circle repeat itself? After 360 degrees or 2 pi, right. And if I look at my graph, I can see that it starts here and it makes one full up and down rotation here at 2 pi. So that means the period is 2 pi. This is all in radians, so we only say 2 pi. But if your x-axis was in degrees, you'd say 360 degrees. Okay? Then it says the amplitude. The amplitude, again, is the height, but from the middle. So how tall is my graph from the middle? 1, exactly. So the amplitude is 1. And that should make sense because the radius of a unit circle is 1. So it's 1 to the top and 1 to the bottom. All right, let's think then about our domain. So the domain of this function, would this wave keep going? In both directions?
Yes.
Yes, it would, because you could keep doing forward or backwards rotations. So our domain is just x as an element of reals. Now our range, can our range keep going up and down? No. The range is always going to stay between 1 and -1. So that means my range is less than or equal to -1, which is less than or equal to 1. So again, y is in between 1 and -1 all the time. So the wave would keep going, but never higher than 1 and never lower than -1. Right, now let's look at cosine from our unit circle. So cosine at 0, I'm just going to switch colors here. Cosine at 0 is going to be 1. Cosine at pi over 2, scroll up here. Scroll. So once you've gone around your circle, you should get those points for cosine. Now we're going to plot the cosine values on the graph. So at 0, it says cosine starts at that 1. At pi over 2, cosine's down to 0. At pi, cosine's at -1. At 3 pi over 2, it's back to 0. And at 2 pi, it's back up to 1. Going the other way, at negative pi over 2, we're at 0. Negative pi, we're down to -1. 3 pi over 2, back to 0. And then negative 2 pi, we're up at +1. Remember, just like sine, you're going to connect these with a nice curvy graph. You should make nice curves. And then that would be your cosine graph. Again, notice that it looks almost identical to the sine graph. It's just moved over. All right, let's look then to the period. So here the period, again, is when it repeats itself. So I see it starts here at 1, and it does one full rotation and gets back to 1 at 2 pi. So the period is still 2 pi. Again, you guys, it should make sense that it's 2 pi, because that's one loop around the circle. The amplitude, how tall is this from the middle? 1. Good. So again, that's talking about the height here. It's 1 unit tall. The domain, Would this keep on going forever in both directions?
Yeah.
Yes, so we say that x is an element of reals. And the range, does the range keep on going forever in both directions?
No.
No. What is the range always between?
-1 and 1.
-1 and 1. Good, so we say that all of our y's are in between -1 and 1. And yes, they can equal -1 and 1, so we put the equal to signs in as well. So when we look at tan, we have to look at every 45 degrees because that's where all of our tan values work out to be nice numbers. So you'll notice that here there's going to be more values in our table. Let's now plot them on the graph. So the easiest way to do your tan graph is to put your asymptotes on first. So you should notice that your first asymptote occurs at pi over 2. So I'm going to draw a dashed vertical asymptote line at pi over 2. Remember, that's because we have 1 dividing by 0, and since you can't divide by 0, that's our undefined asymptote line. Our next asymptote is at 3 pi over 2. So somewhere over there. And then we also have an asymptote at negative pi over 2. So you should see that the pattern here appears to be every 4 squares, or every 4 blocks, there's an asymptote, and that pattern would continue to repeat itself. Now let's just fill in the middle. So at 0, tan was 0. At pi over 4, tan was 1. And at negative pi over 4, tan was -1. At 3 pi over 4, we're at -1. At pi, we're at 0. And at 5 pi over 4, we're at +1. 7 pi over 4 is -1. 2 pi is 0. And a few more on the other side here. We have negative pi, it's at 0, and 3 pi over 2 in the negatives. 3 pi over 4, sorry, that should be 4, is up at +1. So we basically have these dots. Then we have to follow the rule that graphs hug asymptotes. So I'm going to hit these dots, and then I'm going to curve toward my asymptote lines. So the middle one here is the easiest one to see, but you're going to hug that asymptote line, connect your dots, and then go through and keep hugging that asymptote line. Same thing with your next ones. Hit those 3 dots, and then hug your asymptote lines. On the end here, I only have half the graph, and on this end I only have half the graph as well. But again, hit your points, and then hug your asymptote lines. Okay, so with tan, the period is different. This appears to repeat itself more often, and it repeats itself every pi units. So if you look at the distance between where it hits 0, it's pi. And then it's going to keep repeating itself every pi units. The amplitude is how tall it is. Okay? What do you think? It goes to infinity, so we actually say, because the amplitude is distance, okay? That's, by definition, it's distance. So we actually say that the amplitude is undefined. The reason it's undefined is I can't calculate how tall it is, because it keeps going on forever. Then we're going to go to domain. Now domain is tricky. Okay? The domain is everywhere except what? The asymptotes, right. So I have to say here that the domain is x in an element of reals. But then I also say that x cannot equal, I say pi over 2, and then I'm going to say plus pi n. So what this means is that my first asymptote occurs here at pi over 2, and then if I keep adding pi to that, I'm going to keep getting to all of my asymptote values. So again, pi is the period. So if I keep adding pi from my first asymptote, I'm going to find all of my other asymptotes. And the range, this one should be an easier one. It's an element of the reals, right? Because it's going to go on forever up and on forever down. So the range with tan is pretty easy, but the domain is the tricky part. Alright, so then you can just move on to that textbook assignment, and we'll keep going next day.